Hi everyone, just making a quick video on factor by grouping, which is our headphones method. We call it headphones because I can't use 1 a.m. factoring because my leading coefficient is not a 1 and I can't factor out a GCF of 2. So the headphones method states, which is factor by grouping, I take the 2 and the 3 and I multiply them together to get 6. Now I'm looking for two numbers that multiply to 6, but then add up to 5. And then those two numbers are going to be 2 and 3. Now I'm taking the 2x squared and I'm bringing that down. And instead of writing 5x, I'm rewriting it with two terms. I'm going to do a plus 2x plus 3x plus 3. Now from here, I expanded it into 4 different terms. I'm splitting down the middle, and then I'm using GCF factoring. So on the left of that line, the GCF between 2x squared and 2x is a 2x. And when I divide out the GCF, 2x goes in 2x squared with an x left over. 2x goes into that 2x once. Now I repeat the process with GCF factoring on the right-hand side. What goes into 3x and 3 is a 3. And then when I divide out by 3, I have x plus 1 left over. Now our goal is to make sure that these two factors are the same, and they are. So I'm going to write that once, x plus 1. And then my second factor are these GCFs. So 2x plus 3. This right here is my final answer. I factored using factor by grouping. Now, if you wanted to check it out to see if it worked, you could double distribute to make sure that it matches, or you could go into y1 and y2 and type the original and your answer. But if I were to expand this, I do get 2x squared, a positive 2x, 3x, and 3. When I combine like terms, that is my 2x squared plus 5x plus 3, which does match the top. Now that's only if it says factor. If it says solve, like the next one, I'm going to look at this and see, can I pull out a GCF of 5? When I pull out a 5, 5 doesn't go into 28 and the 12 evenly, so I cannot pull out a GCF of 5. You could always use the quadratic formula because this leading coefficient is greater than 1, but I'm just going to use headphones for this problem, which is factor by grouping. I'm taking the 5 and the negative 12, multiplying to get negative 60, and then two numbers that multiply to negative 60 and add up to that negative 28 are negative 30 and positive 2. So I'm taking my 5x squared, bringing that down. Instead of writing negative 28x, I'm writing negative 30x plus 2x minus 12. From here, split down the middle. To the left of that line, what goes into 5x squared and negative 30x is a 5x. When I divide out that GCF, I get x minus 6. On the right-hand side, what goes into 2x and negative 12 is a positive 2. When I pull that out, I have x minus 6 left over. Now from here, these two are the same. I write it once. And then my other factor is 5x plus 2. Now instead of stopping right here because they told us to solve, we're going to set each factor equal to 0. So I have 5x plus 2 equals 0. I have x minus 6 equals 0. Add 6 and 1 solution, 1 root, 1 0, 1 x-intercept is x equals 6. And then divide out by 5, and we get x equals negative 2 over 5. Again, you could have used the quadratic formula for this one, but I just chose to factor by grouping since I know some of you are struggling with that.